So, hello everyone. Session number 9, linear dependence and independence of vector. So, today's session you will learn about linear dependence and independence of a vector. Graphically, if you observe when the vectors are dependent or independent, you will clearly observe here if uh, if the vectors are on the same line of action, means if the vector v1 and v2 have the same direction or they have the opposite direction, means they are present on the same line of action, then they are dependent vector. But if the vectors are on the different lines here, on the different lines, for example here is a first line you will observe and here is another line, so they are on the different line, so they are linearly independent. But the most important thing is a mathematical definition for dependence and independence of vector. It have a very simple rule. Whenever we are able to write the vector, say we are able to write v2 is equal to 2 times v1, or we can say v1 is equal to minus 2 times v2, something like this. Okay, so if in short, if there is an equation between the vectors, if there is an equation between the vectors, so whenever we can write v1 is equal to k times v2. K is a constant, it may be a positive, negative, anyone. K is a real number, you can say simple words. So if v1 is equal to k v2, or v1 plus k v2 is a 0, something like this. If there is equation between the vectors, we say the vectors are dependent. So whenever the vectors are dependent, there exists a relation between them. And when the vectors are independent, such a relation does not exist. You cannot write v1 is equal to k times v2. This is not possible to write. Then they are independent. They are independent. So this is the mathematical definition. So how to solve the examples now? How to solve the examples? To solve the example, what we do it, suppose for simplicity, let me assume we are given three vectors, say v1, v2 and v3, and the question is check whether these three vectors are dependent or independent. So we should start with assuming the equation. Let us assume there exists an equation c1 v1 plus c2 v2 plus c3 v3 equal to 0. And what is our aim? Our aim is to find out the values of c1, c2, c3 by the system of equation. Suppose we get a unique solution, that is a zero solution, c1, c2, c3 as a 0. And if we replace back here as a c1 0, c2 0, c3 0, what happens? We get 0 equal to 0. Means there is no relation. There is no relation exists between v1, v2, v3. So whenever all ci's are 0, we say the vectors are linearly independent. Whenever all ci's are 0, vectors are linearly independent. Otherwise, they are linearly dependent. What is linearly dependent? Means ci's are not 0. When the constants, whenever we get a 0 solution, vectors are linearly independent because that relation does not exist. But if that ci's are not 0, we, for example, suppose c1, c2, c3 are 1, they are not 0. Then we get v1 plus v2 plus v3 is 0. If that c1, c2, c3 are 1, means there is a relation. So they are dependent vector. They are dependent vector. So this is the simple rule that we have. So whenever we have to prove any given vectors are linearly dependent or independent, we start assuming the equation between them, and we find out the values of constant there by the system of equation method, and we say whether they are dependent or independent. So come to the example. So the first example is here. Our aim is to check whether these three vectors, first, second and third, whether these three vectors are dependent or independent. So we should start with as a consider c1 v1 plus c2 v2 plus c3 v3 equal to 0. So this is the step number 1. We'll replace the values of v1, v2, v3 here. So this is the vector 1 v1, this is v2, v3. The next step, yes, next step we can do it. So just multiply this constant inside the vector. So what is the first one? We'll get c1, 2c1, 3c1. So what we done? Just we multiplied c1 inside this vector or scalar to the vector. So we will multiply c2 inside that vector. So we get 0 c2, c2 and 2 c2. Similarly, if we multiply the c3 inside the vector, we get minus 2 c3, 0 c3 and c3 and equal to 0. Now, what is the step one? We started with this one. Step two, we replace the values of vectors, and now we multiplied the scalar inside the vector. Now next thing, we are going to add the three vector. So addition of the vector is nothing but addition of their corresponding component. So these are the component number one. So if you add these three components together, we get C1 plus 0C2 minus 2C3. Remember, at the end, whatever vector we are getting, we are saying that is a zero vector. So when the vector is a zero, if each component is a zero, so the first component is C1 plus 0C2 minus 2C3 is a zero. Next component is a 2C1 plus C2 plus 0C3 equal to 0. And the last component is 3C1 3C1 plus 2C2 plus C3 is a 0. So this is the important step that we got. So what we are doing, whatever the given vectors we are given, with the help of this condition C1 V1, so we get a system of equations for here is there are three unknowns C1 C2 C3. So and it is a homogeneous system, so solution of homogeneous system is decided by the rank of the coefficient matrix A only. So we'll write the coefficient matrix A and we'll reduce it to the row echelon form. So I'm going to show you this system of equation and the coefficient matrix. So here we have these equations, and this is the coefficient matrix. So these are the coefficients of C1, these are coefficient of C2, these are C3, and we have to reduce this matrix to the row echelon form. So a very simple thing, we'll focus on A11 and we'll make these two zeros. So the transformation is obviously we require is R2 minus 2R1 and R3 minus 3R1. R2 minus 2R1 and R3 minus. So 1 0 minus 2 as it is. So these two zeros we require. R2 minus 2R1, so 1 as it is. R2 minus 2R1, it becomes plus 4. R3 minus 3R1, R3 minus 3R1, so plus 6 plus 1 7. So here is the end of step 1. Step 2, with the help of A22 we make the below zeros. So the transformation is again very simple, where we have to do here R3 minus 2R2, R3 minus 2R2, we get 1 0 minus 2 0 1 4, and here is 0 0, and last case R3 7 minus 8 minus 1. What is the rank? Now, the rank of this matrix, rank of the coefficient matrix, because it is in row echelon form, all the entries below main diagonal 0, rank of A is a 3, number of unknown, that is C1, C2, C3 are also 3. So whenever rank of A equal to n, we have a unique solution, that is a zero solution, and because in the homogeneous case, and we get C1 equal to C2 equal to C3 as a 0. Is that clear? All CIs are 0. So if we replace all these CI 0 here, so 0 v1, 0 v2, 0 v3, 0 means 0 equal to 0, relation does not exist. So vectors are linearly independent. That should be the final answer. Hence the vectors are linearly independent. So this is a way, yes, we can check whether the vectors are dependent or independent. When all the constants coming 0, the vectors are linearly independent. Actually, if you're not able to get this CI 0 directly, you can write the last these three equations back again. C1 minus 2C3 is a 0, C2 plus 4C3 is 0, minus C3 is 0, minus C3 means C3 0, C3 0 means C2 0, C2 0 means C1 0. That is the way. Okay, so this is the way we solve the homogeneous system, and as all constants are 0, we are saying the vectors are linearly independent. So whatever the set of vectors are there, so they are linearly independent. One more example. Now we are given these three vectors. Our aim is to check whether they are dependent or independent. If dependent, there is extra part in the question. If they are dependent, we have to find the relation between them also. Okay, that is the extra part. So step 1, consider C1 V1 plus C2 V2 plus C3 V3 0. So replace the values of V1, V2, V3 which are given in the example and create the system of equation. Write a coefficient matrix. Okay, up to this, yes, we got the coefficient matrix. Our aim is to convert this in the row echelon form. So we have to make these two zeros with the help of A11, and the transformation goes to say R2 minus R1 and R3 plus 2R1. 1 2 0 is the first row. Second row is these zeros we have, R2 minus 5 minus 2 is a 3, 1 minus 0 is 1. So 1 minus 1 plus 2R1 is there. So 4 minus 1 plus 4 is a 3 and 1 only. So obviously a very simple step we left now. With the help of A22 we have to make this 0 and the transformation will go like this. That is R3 minus R2. And we got here 1, 2, 0, 0, 3, 1, 0, 0, 0. See the rank of A is a 2 and number of unknowns are 3. Infinite solution, whenever we have infinite or non-zero solution, the vectors becomes linearly dependent. So we have to find the relation between them also. So let me write these equations back again. The first equation is a C1 plus 2C2 is a 0. Second equation is a 3C2 plus C3 is a 0. That's one. Now we have two equations for 3 unknown. So let me assume C3 as a T. If C3 is a T, if C3 is a T, you will observe 3C2 plus T. 3C2 plus T is a 0. So C2 becomes minus T by 3. C2 is a minus 2 by 3, sorry, minus T by 3, which we got from this equation. In this equation, now we replace the value of C2. So it is 2C2. So minus 2T by 3. So C1 becomes plus 2T by 3. So we got this infinite solution. Now after this infinite solution, yes, there are infinitely many values for C1, C2, C3. We are interested for at least one value of C1, C2, C3. And the best value that we can replace for T is a 3. Why we replace T by 3? To remove the fraction. So if we replace T equal to 3, we get C1. C1 becomes 2. C2 becomes minus 1 and C3 becomes 1. C3 becomes 1. Now just we replace these values of C1, C2, C3 in this equation and we get that relation between them. So C1 V1 means 2 V1, C2 V2 means minus V2 plus C3 V3 means plus V3 is a 0. That is a relation between the vector. As a relation exists, we say the vectors are linearly dependent. You can say the vectors are linearly dependent after this step also, because whenever there is a non-zero solution, the vectors are linearly dependent. But yes, we shown the vectors are dependent, and yes, there exists a relation, and that relation also we shown here. 2v1 minus v2 plus v3 equal to 0. You can cross check also by replacing the values of v1, v2, v3 in this expression. But no need, as if you are confident on your calculation, no need to cross check. Okay, so that about the dependent and independent of vector. So with two simple examples, I shown you how to prove the vectors are dependent or independent. Here vectors are dependent and the relation exists as a, these are the values of c1, c2, c3. Okay, so thank you.